All right, today we are unlocking a secret code. It's a mathematical language that, believe it or not, governs just about everything, from how galaxies grow to the interest on your savings account. We're going to dive deep into exponents, radicals, and logarithms.
So let's just start with this idea. What if numbers could just explode, growing at this incredible rate? Or what if you could actually rewind that growth and pinpoint exactly where it all started? I know, it sounds like something straight out of science fiction, right? But it's not. This is exactly what these three incredible math tools allow us to do.
Okay, so let's get into it. Our journey starts way back in the ancient world, with a single idea that was so brilliant, it pretty much changed math forever. Let's talk about the birth of the exponent.
We're actually going to follow three key figures here. We start with Archimedes, back in ancient Greece. He's the one who planted the first seed. Then, centuries later, we have Al-Khwarizmi in Baghdad, who came along and asked the first, "What if we go backwards?" question. And finally, John Napier in Scotland asked the other inverse question, and that's what really completed the whole puzzle.
So it all started with Archimedes and this really simple but incredibly powerful idea of the exponents. It's that little number that kind of sits on top of another one. And it's basically a shortcut. It's like a command that says, hey, instead of writing out this super long line of multiplication, just tell me how many times to multiply the number by itself.
I mean, just look at this example. Writing 2 to the 5th power is just so much cleaner, so much more efficient than writing out 2 times 2 times 2. You get the idea. This was a revolutionary shortcut. It let mathematicians work with absolutely huge numbers way more easily.
Okay, so let's lock in the vocabulary here. It's really simple. The main number, the a you see here, we call that the base. And that smaller number up top, the m, that's the exponent. The exponent tells the base what to do. Just remember those two terms, base and exponent. We're going to be using them a lot. So, once mathematicians totally mastered the idea of growth, what do you think the next logical question was? Yep, how do we reverse it? And that's what led to two totally different ways to work backwards.
And I love this quote because it just captures the idea perfectly. If exponents are the engine of mathematical growth, pushing everything forward, then radicals and logarithms, well, they're the brakes. They let us slow things down and work our way back to the start. Now, this slide right here is absolutely key to understanding the difference. So both radicals and logarithms are the inverse of exponents, right? But they're solving for different missing pieces of the puzzle. Radicals ask the question, what was the original base? Like the square root of 49 is 7, because 7 was the base you had to square to get 49. But logarithms ask a different question, what was the exponent? For example, the log base 2 of 8 is 3, because 3 is the exponent you need to raise 2 in order to get 8. See the difference? One finds the base, the other finds the exponent. Okay, so let's jump out of the history books and bring this right into your world. Let's see how these amazing historical discoveries actually translate into the rules you use on your homework today.
All right, our first rule, and I'll admit this one can feel a little strange at first. Any number, as long as it's not 0, raised to the power of 0 is always 1. Doesn't matter if it's 5 to the power of 0 or 1,000,000 to the power of 0, the answer is just 1. It's a really important rule to help keep the whole system of exponents consistent.
Now, negative exponents. I know they can look kind of intimidating, but they're really just a simple flip command. When you see a negative exponent, it's just telling you to move the base to the other side of the fraction line and then make the exponent positive. So like 2 to the negative 3 just becomes 1 over 2 to the positive 3, which is just 1/8. It's really that simple.
Okay, this is where it all really comes together, and it's so cool. A fractional exponent is just a radical in disguise. The number on the bottom of the fraction tells you what root to take, and the number on top tells you the power to raise it to. This just shows you how deeply connected these ideas of exponents and radicals truly are.
Now, this is a super common trip-up, so listen close. When you've got a negative base, it all depends on the exponent. If you raise a negative number to an odd power, the answer stays negative. Think negative 2 cubed is negative 8. But if you raise it to an even power, the answer becomes positive. Negative 2 squared is positive 4. That's just because with an even power, all those pairs of negative signs cancel each other out.
So, we've traced this whole story from ancient thinkers all the way to the rules on your homework sheet. But why does this code really matter today? Well, because this stuff, it's everywhere.
I'm talking astronomers using it to figure out how planets orbit, engineers using it to design skyscrapers,
Economists using it to model how markets grow. This isn't just about passing a math test, you guys. This is like the fundamental operating system of modern science and technology.
So the next time you're solving for x, just remember this. You're not just doing homework. You are working with the very same mathematical magic that Archimedes, Al-Khwarizmi, and Napier used to decode the universe and literally shape human history.
And you know, that really brings us to our final question. We've seen how this code completely shaped our past. The real mystery is, what will you do with it? What new secrets of the universe are you going to unlock? Thanks for joining me.